Somewhere in the distant universe, there is a single object that may outweigh every star in the Milky Way combined. It is not a galaxy. It is not a cluster. It is one black hole. And by every standard model of how black holes grow, it should not be this big, this early in cosmic history. Its name is TON 618. It sits at the heart of a quasar so bright it drowns out its own galaxy. We cannot even see the hundreds of billions of stars surrounding it, because this one object outshines them all, blazing with the energy of 140 trillion suns. The light we see from TON 618 left its source 10.4 billion years ago. We are looking at something from an era when the universe was barely 3 billion years old. Young, violent, and building monsters we still cannot fully explain. So when we look at TON 618, we are not just looking far away. We are looking back in time. This is the story of the most massive black hole ever directly measured. How we found it. How we weigh something we cannot see, why its own mass challenges the rules of physics, and what it might look like right now, 10 billion years after the light we see today began its journey. One note on distance before we begin, because this will come up. The light from TON 618 traveled for 10.4 billion years to reach our telescopes. But the universe has been expanding the entire time that light was in transit. So the object is no longer 10 billion light-years away. Its current distance is roughly 18.2 billion light-years. That is not a contradiction with the age of the universe. It is simply what expansion does to space over deep time. In 1957, astronomers in Tonantzintla, Mexico, were running a sky survey, cataloging faint blue objects near the constellations Canes Venatici and Coma Berenices. Object number 618 in that catalog was unremarkable at first, a faint blue point of light, one among thousands. It took over a decade before anyone understood what they were looking at. In 1970, new spectroscopic observations revealed something that did not make sense. When astronomers split the light from this object into its component wavelengths, the spectral lines were in the wrong place. They were shifted dramatically toward the red end of the spectrum. In cosmology, redshift means distance. The greater the shift, the further away the object. And the redshift of TON 618 was enormous. That meant it was not a nearby star. It was not even in our galaxy. It was billions of light-years away. And here is the part that stopped people. If something that distant could still appear that bright from Earth, then the energy it was producing was beyond anything astronomers had ever calculated, not by a small margin, by orders of magnitude. TON 618 was a quasar. Quasar is short for quasi-stellar radio source, a name from an era when we did not yet understand what these objects were. Today we know. A quasar is the visible signature of a supermassive black hole that is actively feeding. The black hole itself is invisible, but the disk of gas spiraling into it, the accretion disk, gets compressed, superheated, and accelerated to a significant fraction of the speed of light. That process converts matter into energy with roughly 40% efficiency. For comparison, nuclear fusion inside our sun converts matter into energy at less than 1% efficiency. That is what makes TON 618 visible from across the observable universe. Not the black hole. It is the destruction surrounding it, and that destruction extends far beyond the accretion disk. Observations have revealed that TON 618 is surrounded by an enormous cloud of glowing gas called a Lyman-alpha nebula. This structure stretches at least 100 kiloparsecs across. That is over 300,000 light-years, roughly twice the diameter of the entire Milky Way galaxy. A single black hole, illuminating and energizing a gas cloud larger than most galaxies. The radiation pouring off TON 618 does not just light up its immediate surroundings, it reshapes the gas environment for hundreds of thousands of light-years in every direction. Think about that for a moment. A black hole, an object defined by the fact that nothing escapes it, is powering one of the brightest beacons in the entire cosmos. The darkest thing in the universe produces the most light, not despite its gravity, but because of it. And the scale is difficult to hold in your mind. If TON 618 were placed at the center of our Milky Way, 27,000 light-years from Earth, it would not be a dim point in the sky. It would be brighter than the full moon, visible in broad daylight. A second sun that never sets, glowing an unsettling violet from the extreme ultraviolet radiation pouring off its accretion disk. If it were only 187 light-years away, roughly the distance to some stars you can see with the naked eye, it would match the brightness of our actual sun. Every planet within that radius would live under the light of a black hole. Let that image settle. A black hole, lighting entire solar systems. Here is the question that drives everything else. How do you measure the mass of something you cannot see? Something so far away that even its galaxy is invisible behind the glare? The answer is one of the most elegant methods in astrophysics, and almost no one talks about it. It is called the virial method. The idea is beautifully simple. Around TON 618, clouds of gas are orbiting at tremendous speed. We know this because the light from that gas is broadened. Some of it is blue-shifted, moving toward all of us. Some is red-shifted, moving away. The width of those emission lines tells us exactly how fast the gas is moving. Now here is the key. If you know how fast something is orbiting, and you know how far it is from the center, you can calculate the mass of the thing it is orbiting. The same principle lets us weigh the sun by watching how fast Earth moves around it. The faster the orbit, the more massive the central object must be. When astronomers applied this method to TON 618, the number that came back was staggering. 66 billion times the mass of the sun. One object. 66 billion solar masses. That is more than the combined mass of every star in the Milky Way galaxy. Our galaxy contains between 100 billion and 400 billion stars, but most of them are small red dwarfs. Add all their masses together and you reach roughly 60 billion solar masses. TON 618 exceeds that total alone. Its event horizon, the boundary beyond which nothing returns, has a radius of approximately 1,300 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun, so the event horizon of TON 618 stretches 1,300 times further than that. Neptune, the outermost planet in our solar system, orbits at about 30 astronomical units. That means you could line up over 40 copies of Neptune's orbit side by side, and they would fit inside the event horizon of TON 618. Our entire solar system, from the Sun to the farthest reaches of the Kuiper Belt, is a small coin compared to this object. Here is a simpler way to feel it. Light, which crosses the entire distance from the Earth to the Sun in 8 minutes, would take approximately 2 weeks to cross TON 618 from one side to the other. 2 weeks at the speed of light, just to traverse one object. If that number surprised you, hit like, because it is about to get stranger. The 66 billion solar mass figure comes from a 2004 study by Schemmer and colleagues. But in 2019, a team led by GE re-examined the emission lines using updated models and revised the estimate downward to 40.7 billion solar masses. That is still monstrous. 40 billion suns compressed into a single point. But the gap between 66 billion and 40 billion is not a rounding error. It is 26 billion solar masses of uncertainty. That is the mass of a mid-sized galaxy, unaccounted for. This is not a failure of science. This is the reality of measuring objects at the edge of the observable universe. The virial method depends on assumptions about the geometry of the gas clouds, the angle at which we are viewing them, and how the emission lines are modeled. Small changes in those assumptions produce large changes in the final number. So which figure is correct? Both papers are peer-reviewed. Both use sound methodology. The honest answer is that TON 618 almost certainly has a mass between 40 and 66 billion solar masses, and the true value may sit somewhere in between. What is not in dispute is the category. This is one of the most massive single objects in the known universe, regardless of which estimate you use. Here is where TON 618 moves from remarkable to impossible. Black holes do not grow without limits. There is a speed limit on how fast a black hole can feed, and it is set by its own radiation. As matter falls into the accretion disk, it heats up and radiates outward. That outgoing radiation pushes against incoming matter, creating a ceiling called the Eddington limit. The more massive the black hole, the harder it can pull. But the harder it pulls, the brighter the accretion disk becomes, and the more it pushes new material away. This creates a natural growth cap. A black hole feeding at the Eddington limit can roughly double its mass every 45 million years. Sit with that number for a moment, because it is about to cause a problem. TON 618 existed when the universe was approximately 3 billion years old. If it started as a stellar remnant, say 100 solar masses from the collapse of an early massive star, it would need roughly 29 doublings to reach 66 billion solar masses. At 45 million years per doubling, that requires over 1.3 billion years of continuous maximum feeding with no interruptions, no gas shortages, no disruptions. Most models consider that extremely unlikely. The timeline does not work. The universe was not old enough. This is the formation paradox, and it is not the only barrier. In 2008, physicist Andrew King proposed a separate theoretical ceiling, now informally called the King limit. King argued that once a black hole reaches approximately 50 billion solar masses, its accretion disk becomes so physically enormous that the outer regions collapse into stars before the gas can fall inward. The black hole effectively shuts off its own fuel supply. If this limit is real, then TON 618 is sitting right at the theoretical maximum. It did not just grow large, it may have grown as large as physics allows. So how did it get there? The leading explanation is direct collapse. In the early universe, enormous clouds of primordial hydrogen may have bypassed normal star formation entirely, collapsing directly into black holes with initial masses of tens of thousands of solar masses. These heavy seeds would have required far fewer doublings to reach ultramassive scales within the available time. Another possibility involves brief episodes of super-Eddington accretion, chaotic periods where the gas supply was so dense and turbulent that radiation could not effectively push it all away. There may also be mechanisms we have not identified yet. The early universe was a different environment, and TON 618 grew in conditions that no longer exist anywhere in the cosmos. This object is a fossil from an era we cannot recreate and do not fully understand. Now imagine approaching it. Everything you know about black holes tells you that getting close means destruction. Spaghettification, the stretching of matter by tidal forces, is the famous death. But TON 618 inverts that expectation. Because its mass is distributed across such an enormous event horizon, the tidal gradient at the boundary is surprisingly gentle. The difference in gravitational pull between your head and your feet at the event horizon of TON 618 is almost negligible. You could cross the event horizon and not feel it happen. No alarm, no wall, no moment of contact. Just a silent, invisible boundary. You would drift inward, and for perhaps another week, you would feel nothing unusual. The spaghettification that shreds objects near smaller black holes would not begin until you were deep inside, falling toward whatever lies at the center. And outside, something stranger happens. Extremely close to the event horizon, time itself distorts beyond recognition. Hover just above the boundary, and 60 seconds of your experience could cost roughly 26 years back on Earth. 2 minutes, and everyone you have ever known would be gone. The object does not just warp space. It warps time so severely that proximity to it is a kind of exile from the rest of the universe. If this channel is giving you a new way to think about the universe, subscribe. This is video 2 in our series on the most extreme objects in the cosmos, and it only gets stranger from here. Before we reach the end, we need to address something that will appear in the comments if we do not address it here. Phoenix A. In 2022, researchers estimated that the black hole at the center of the Phoenix galaxy cluster may have a mass of approximately 100 billion solar masses. If accurate, that would make it significantly more massive than TON 618 by any estimate. But here is what most people leave out. The mass of Phoenix A was not measured the same way. TON 618 was measured using the virial method, the direct observation of gas dynamics around the black hole, calibrated against known physics. Phoenix A was estimated using a model of how the black hole interacted with the hot gas in its surrounding galaxy cluster over cosmological time. That method depends on assumptions about feedback efficiency, growth history, and cluster structure. It has not been extensively verified, and the error bars are enormous. The 100 billion figure is best treated as an upper limit, not a confirmed measurement. The lower estimates for Phoenix place it closer to 20 to 40 billion solar masses, which would make it comparable to or even smaller than TON 618. So is Phoenix a bigger? Maybe. Is that measurement as reliable as TON 618? Not yet. Is inference as good as direct observation? That is one of the real debates in astrophysics right now. Some physicists say yes, others say the methods are not yet mature enough. TON 618 remains the most massive black hole whose mass has been directly measured through observed gas dynamics. That distinction matters. Now, here is the question almost nobody answers. What does TON 618 look like right now? We see it as it was 10.4 billion years ago. Back then, it was a quasar, actively feeding, blazing across the universe. But quasars do not last forever. They burn through their fuel supply. The gas runs out. The accretion disk thins and dims. The jets lose power and fade. At some point over the last 10 billion years, TON 618 almost certainly went quiet. The quasar turned off. What remains is the black hole itself, still just as massive, possibly more so from billions of additional years of mergers and slow feeding. But dark now. Silent. No longer the blinding violet beacon it once was. Just an enormous sphere of warped space-time, sitting at the center of a galaxy we have never seen, exerting its gravity on stars that orbit without knowing what holds them. It is possible that the galaxy around it has grown, that new stars have formed in the calmer environment left behind after the quasar era ended. That somewhere in that galaxy, planets exist, orbiting in complete ignorance of the colossus at the center. The monster is still there. It simply stopped screaming. But its light did not. For 10 billion years, the light from TON 618 traveled across the expanding universe, passing through voids where nothing exists for hundreds of millions of light years. And after all that time, all that distance, that ancient light arrived here, at our telescopes, in our sky. Every civilization that has ever looked up in the last 10 billion years could have seen the same beacon. We are among the last to see it. Each year, the expansion of the universe carries TON 618 further beyond our reach. Eventually, its light will redshift past detection. The beacon will fade from every telescope, in every galaxy, forever. TON 618 is not just a black hole. It is a signal from an era of the universe that no longer exists. And it raises a question that should keep you up at night. What else is out there, in the dark, that simply turned off its light before we thought to look? This is video 2 in our Cosmic Extremes series. If you are here for the science and not the hype, subscribe. Next, we hunt for the answer. We look at Phoenix A, the black hole that might be larger, and at the measurement war that could rewrite the record books.